Hi everyone, today I'm going to talk about solid principles. So basically solid principles is a way of remembering the 5 design principles for object-oriented design to create better software. So I'm just going to dive into them. I'm not going to do them in order purely just because I've got examples that work better out of order. The examples are all going to be available in C#, but they're applicable to other object-oriented programming languages as well. So I'm going to start off by explaining the open-closed principle. So basically a class or method should be open for extension but closed for modification. I'm going to talk you through an example and why it is a good principle to follow. So here we have a blank C# console application that I'm going to add a file to. So I'm going to add a person class and I'm going to use that as the basis for my examples. So you can see that that's got an empty constructor. It's in that namespace solid principles. I can add the semicolon to make it a file namespace and just reduce the indentation required inside the class. I'm going to add a few properties. So a property is basically like a field except it's got getters and setters. I'm just using a default getter and setter, which means I can set and get the name inside and outside of the class because it's public. I'm also going to create a virtual method called getInfo. Basically what that means is anything that subclasses person can override the method and provide their own implementation. So I'm just going to specify that getInfo prints out the name of the person. It's going to be a very simple class. Now what I'm going to do is I'm back in my console application. I'm just going to create a new person called Jane Doe and I'm just going to print out their info. That should just print out their name, which is Jane Doe. If I run it, I should see Jane Doe printed out to the console and you can see that I have. Now let's say that we wanted an employee, so we might want to be able to add an employee code or something like that and be able to output that information as well. We could add it to the existing person class, but that would basically be modifying the existing class and sort of adding lots of extra responsibilities onto it. So we don't want to do that. What we're going to do is we're going to extend person. So person is open for modification, or open for extension and closed for modification. And this is what we're demonstrating here. Basically, we're extending its behavior by subclassing it as an employee, and we can provide different info such as the name, employee code, hourly rate, and tax rate. And we can just send whatever we need to the person class by using that base constructor. So I can add properties to hold each of these additional values that I want to hold, like the employee code, the hourly rate, and the tax rate. And I can set those accordingly. Then I can go ahead and override our getInfo method, and I can provide my own implementation of that, which is going to provide additional info such as the employee code back to the user. So we're still going to provide that name back, but we're just going to provide some additional data back, and that's how we're extending the person. So our person class is closed for modification, open for extension. The reason we might not want to update our person class is it actually means that anything that already is using the person class then gets that new implementation, and it may not work in cases that they expect it to work, and so it's sort of changing the existing logic and can cause issues elsewhere in the code. So by extending it instead, we're sort of building more resilient and reliable code here. So I'm creating a new employee, and I'm just going to call him Terry Watts, and I'm going to pass in his employee code, his hourly rate, and his tax rate. And then I'm going to call that getInfo method, and that's going to write to the console, and I'll be able to see the additional info that the employee has because I've extended the person class. So you can see he's got additional info such as the employee code, hourly rate, and tax rate printed to the console. Next up, I'll be explaining the Liskov substitution principle. So basically what that is that objects of a subclass should be able to be provided in place of a superclass without the correctness of the program being affected. I'm going to follow on from our example and show you how this is in practice. So we have an employee, which is a subclass of a person, and so basically we should be able to assign an employee to the type person, and it should work as expected because employee is a subclass of person, so it has all the same methods. It's not going to break anything. The only thing that will happen is that it may have overridden methods which would provide additional implementation logic that is specific to the child class. So in this case, it will provide additional information because the employee has additional information against it. So I've defined a person variable with the name a person, and I've assigned my employee to it, and I'm going to just do an person.getInfo, and it's going to call the getInfo of the employee class. So it's going to provide the additional information even though the variable a person is of type person, not employee. It still provides that additional information because I've assigned an employee to the type person. So now I'm going to circle back to the single responsibility principle, which is that a class should have only a single responsibility or only one reason for change. So the reason this is important is basically to limit changes to a class and sort of keep things a bit more isolated and decoupled. So I can show you that in this example that follows. So with an employee, a common thing you might want to do is actually get their salary. So I'm going to provide a method here that would allow you to get the salary of the employee. So it's going to be called calculate pay, and it's going to take in the amount of hours they've worked, and from there I can calculate their salary. I'm just going to do it simply by timing their hours by their hourly rate. So that's all well and good, right? But say the way we're going to calculate pay changes, then we'd actually need to go and make changes to the employee class, and so there wouldn't be a single reason to change. So what we could do is we could actually extract that calculation out into a separate class, and that way if there is any need to change the calculation of pay, we don't actually need to change that employee class, and it can sort of be calculated externally and we know that we're not making any changes to the actual employee class itself, and there's less risk that we're going to break things inside there or anywhere that actually calls the employee class, because they might be relying on the old implementation, and you going ahead and changing that might cause some issues. So I'm just going to create an employee, and this employee, I'm just going to show you that salary calculation works just so we can get a starting value, and then I'm going to go and refactor it to show you how I would approach this if I was following the single responsibility principle. So we have our new employee, so I'm just going to console.writeLine their salary. So I'm just going to call that calculate pay method, and I'm going to pass in a number of hours. And that will output to the console the pay that they receive for working 2.5 hours. You can see I can't actually call calculate pay on a person, and that's because even though they are of type employee, the variable is for person, so I'd have to cast it before doing that calculate pay method, so that C# knows that it's an employee and I can actually call this method on it, because previously it was thinking it's a person. So you can see that I've got an output value for the pay, and that's my starting point. Now I'm going to want to go ahead and refactor that so that if there's any reason to change the calculation of pay, our employee class doesn't need to change. So for example, I might want to just add $50 every time someone is paid, in which case I could change that calculate pay and it would output like that. It's increased by $50 just because that's what I've decided, but I don't want to be changing it inside the employee class. I want to sit externally so that if there's a reason for it to change, it doesn't impact the employee class itself. So now I'm going to go ahead and extract my salary calculation logic out into its own class. I'm going to call that class gross pay calculator, and it's going to have a constructor that takes in the hourly rate, and the reason is I need that for the calculation of the pay, but I don't actually need the tax rate here because there's no tax for gross pay. That's just the total value, and it doesn't include how much you're being taxed. It doesn't deduct that from your total amount. So I'm going to go ahead and set the hourly rate property, and I can add a method that is going to do the calculation for me. The benefit of this is if I have to make a change to how salary is calculated, I only need to update the one place. It's going to be in the gross pay calculator, and anywhere that uses the gross pay calculator will be updated accordingly without me having to go around and figure out where the individual calculations have been made. So I don't need to go around and accidentally miss a calculation that would cause things to be different in different places. So then I can go ahead and use my gross pay calculator from within my employee class. I'm going to pass in the hourly rate, and I'm going to calculate using the hours. This will return the same result as our initial calculation, except it just means that if any changes need to be made in the future, it's a little bit easier and cleaner to make them. So I've still got that 55.5, and if I added 50, it would go to 105.5, just like I had previously. Cool, so you can see that's all working as expected. Another one of the principles is interface segregation, and this is that clients should not be forced to depend on methods they do not use. So I'm just going to go ahead and give you an example of this. So basically what this principle is about is breaking down your interfaces into quite small sort of isolated interfaces that have very narrow scopes, And that just means that anything that is depending on an interface doesn't depend on any additional methods that they're probably not going to require. Like anything that's implementing an interface doesn't need to leave any methods unimplemented because they're not relevant for the actual class. So for example, here I've got an non-remote employee, and that one is going to have a transit to work method. But if I had a remote employee, it wouldn't make sense for them to have a transit to work method because they're not transiting, they're remote, they do not transit, they're just going to work remotely. So that's why I might create a very isolated interface for that. And I can create a new class, non-remote employee, that is going to extend employee. So it gets all the behavior of employee because it's a subclass of employee, but it's also going to implement the non-remote employee interface. So it's going to have this additional method in it that is about transiting to work. So I've got the same sort of data that I need passed into the constructor because I'm going to need to pass that to my superclass via the base constructor. So I'm going to do that here. This is basically the shorthand in C# to call the base constructor and pass the relevant data through to it. I then need to implement the transit to work method, and so I'm just going to do a console.write line in there that basically says that it's transiting to work. Hi ho, it's off to work we go. So if I tried to console write line AB, I wouldn't be able to call the method transit to work because it's of type employee. But if it were of type non-remote employee, then it would have that transit to work method available to it, and I could call that. So I'm creating a variable now that is of type non-remote employee. And I'm going to instantiate that. I'll pass in some a name, an employee code, an hourly rate, and also a tax rate. So because that is of type non-remote employee, I can call transit to work. You can see that the employee doesn't need to have that transit to work implemented in it because I've specified it as a very separate and well-defined interface that is very specific in its nature. And so any sort of methods that relate to a non-remote employee could go in that interface. When defining my variable, I can also just say the type is of non-remote employee because I might not particularly care what specific implementation of a non-remote employee I have. I might have other ones such as like a courier driver or a doctor because they will have to go to work and be physically present to perform their responsibilities as a doctor or a courier driver. So now I'm just creating another example to show you that I can have sort of multiple implementations of a non-remote employee. So this one's the delivery driver employee. It's going to be pretty much the exact same. It needs to extend the employee class, as I'm going to make it like an employee, but it also needs to implement the non-remote employee interface because they can't perform their job without being physically present, and they are not a remote worker. Because I'm implementing that non-remote employee, I'm going to need to implement that transit to work method, and because I am I'm extending employee, I need to call that base constructor of employee. So now I'll go ahead and implement my transit to work method for the delivery driver, which is just going to say delivering. So if I were to create a new variable of non-remote employee type, I can specify my delivery driver. So I can create a new instance of a delivery driver employee, give it a name, an employee code, an hourly rate, and also a tax rate, and then I can call that transit to work function on it, or method on it. You can see that I didn't have any of the other methods available to employees, such as calculate pay, and that's because I've specified the type as non-remote employee. If I wanted to be able to call those additional methods, I would need to specify the type as either delivery driver employee or employee. But if I specified it as employee, I wouldn't have access to the transit to work method. And it's just sort of showing a bit of separation of concern. So I only have access to the sort of methods that are relevant to me, and at this point I only want the transit to work method, so I can define it as of type non-remote employee. So you can see there that I don't have access to that calculate pay because we have it of type non-remote employee. Because I do know it's a delivery driver employee, I can cast it. But if I were to actually want to access this, I might prefer to specify the type up front so that I don't need to cast it. You can see I can calculate it if I do cast it though. And I can also call that getInfo method if I cast as well, because that's available on the employee class. And the final principle is dependency inversion. So that's basically that we should depend upon abstractions, not concrete implementations. And I'm going to show you an example of this now. Previously, we had the employee reliant on the gross pay calculator so that we could calculate the pay. But what if we wanted to provide different implementations of the calculations? We might want to invert the dependency on the gross pay calculator so that we are passing in the dependency, and it will make our code a bit more flexible to different situations. In some cases, we might want to calculate the net pay. Other cases, we might want to calculate the gross pay. And in other calculations, we might want to provide a specific calculation where we're giving the employee a bonus on top of their pay. So to do that, we're going to invert the dependency by providing an implementation of a calculator, a pay calculator. So I'm going to create a net pay calculator here, and I'm just going to have it taken the hourly rate and the tax rate, as that's what it's going to need to perform its pay calculation. It's basically going to calculate what the pay would be after taxes have been applied to the pay. So I'm going to implement the method calculate, as that's going to be how I calculate my pay. And I'm just going to return the total value, which is the hours times the hourly rate times by the reduced amount due to the tax rate. And here inside this calculate pay, inside the employee, I'm going to use the net pay calculator instead. I'm going to need to specify the tax rate here as the net pay calculator requires it. But you can see that I actually have to make a change to the employee to do this, and this is what we want to avoid. We don't want to be changing the employee class. If we want to change the calculation, we want to pass in the calculator so that we can apply the calculations without having to make changes inside the employee class. So I'm going to add a new interface, and it's going to be of type iPay calculator. It's typical in C# to prefix your interfaces with the letter I, and that sort of just shows you that they're an interface. And it's going to just basically specify that anything that implements the iPay calculator interface is going to have the calculate method, and it's going to take in the number of hours an employee has worked. I want my net pay calculator and gross pay calculator to implement this, and then I can just pass in either one wherever a type of iPay calculator is expected, and I can then use that to change the pay rate, change how the pay is calculated for the employee without actually having to change any code within the employee class itself. So now both my gross pay calculator and net pay calculator implement the interface iPay calculator. I can actually just pass into the method my calculator that I want to use, or I could pass it in via the constructor. I'm going to choose to pass it in via the constructor just for now, but you could do it either way. It just depends on your use cases, really. So now I need to take in a pay calculator into my constructor and set that pay calculator property. And then within my calculate pay method of the employee, what I'm going to want to do is I can actually use my pay calculator to perform the calculations, and I don't actually need to change any code here. If the calculation changes, I just need to pass in a different calculator when instantiating my employee. If I wanted it to change what calculation to use for the same instance of the employee, that's when I'd pass it in via the method, so that I could go ahead and calculate the pay differently each time I call that calculate pay method. But I'm just going to specify it up front for the employee, and every time I call calculate pay for that employee, it's going to use that same instance of a gross pay calculator that I've defined. Or a net pay calculator. So here I am, I'm just fixing up my employees. They now all need to have a iPay calculator passed into them. So that could be of type gross pay calculator or net pay calculator. I'm also going to need to update my non-remote employee because that also needs to call that constructor for the employee, and it extends employee, so it needs to have its own iPay calculator available to it. And that's the same for delivery driver employee as well. And that's kind of why it's important to make good decisions up front and sort of know what you're going to have in your code, because you don't want to be going through and making all these changes. It's a bit tedious, and you don't know like how many instances of something you're going to have. But if you make things flexible enough, you can sort of avoid these sort of changes after the fact. Well, as much as possible. There's always going to be changes that will be a bit tedious at times, but with good design, you can sort of preempt those. So now I've defined all my iPay calculators, and I have passed them into my different employees so I can run my code. You can see that I've got that gross amount outputting for the employee Annie Bates, because that's where I'm doing that calculate pay, and I've passed in the gross pay calculator, and that's why it's giving me the gross value. But I could go ahead and I could actually pass in a net pay calculator instead, and what that would do is it actually calculate the net pay and output that, because I've inverted the dependency and I don't need to depend on it within that class. I've just sort of got a dependency on a non-concrete type, and so any implementation that I want to pass in, I can pass in. I don't need to make any changes to the employee, and it will just perform the calculation based on what I've passed in. So no changes need to be inside my actual employee class, and I'm keeping my changes quite isolated. So here I am, I'm passing in the net pay calculator that I've just instantiated, and if I go ahead and run that, you can see that I've got a different value coming out because I've passed in the hourly rate and the tax rate, and the net pay calculator calculates the value less tax. I'm not going to do any validation here. I think that's outside the scope of this, but you'll be able to see that it's quite flexible what calculation is used. I don't need to recompile and make the change. I can actually just use an option and determine what calculator I'm going to use based on that. So different companies might have a different option that they want to provide the calculated pay in, and we don't need to make any changes to the code to do that. We just need to know what the company's option is and provide the correct calculator dependent on that. So if the user specifies the net pay calculator as their preference, it's going to provide the net pay calculator, otherwise it'll provide the gross pay calculator. So now I can see my option. I chose net, and so it's giving me the net value. But if I were to rerun that and choose gross, so enter a G, then it would give me the gross pay value. And you can see it's giving me 55.5, which is the gross pay value. So you can sort of see how useful that can be and help aid your design. If you've enjoyed this tutorial, please like and subscribe for more content, and all my code will be available on GitHub.